Molweni grade 12s. This is Mr. Mnyaka speaking to you. This is our first video. Injongo yethu apha ku-assista nina matriculants. So make sure you participate with us. Into esiyifunayo ke is to deal with difficult questions abaxakana nazo abafundi in examinations. So today I'll be highlighting some few things kwi-organic chemistry where abafundi bafumana khona ingxaki. Then xa ndisuka apho ndiphume ndiye nje kwi-questions ezimbadlwana. Then from there we'll end the video. Make sure you ask us questions because we may not know uba abafundi baxakwe yintoni. So kolunga kakhulu kube luvuyo nakuthi if you ask us questions so that we will know about what problems are you encountering. So let's do, guys, physical properties. That is where I saw the problem. I believe you already know about inorganic chemistry where you have to write isomers, mentioning IUPAC name and all those things. I believe you don't have a problem with those things. Then if maybe you have some problems, you'll update us, you see. But now I'll focus on those important points. Then I'll hear other things from you. Okay, it's fine. The physical properties is the sithetha ngazo. Zintoni physical properties? Physical properties is boiling point, melting point, and vapor pressure. Ezi zinto zontathu zizinto ezifumanekayo in any matter in the earth. So apha emhlabeni zizinto ezifumanekayo ezi physical properties zakho ziyafumaneka, you see. So it's very important uba uzazi uba ezi zinto zi-operate njani, zizi-affecta njani i-organic molecules, because now sizozijonga i-organic compound. So apha we know already, I believe you know, into yoba i-boiling point and melting point are inversely proportional to vapor pressure. That means if you increase the boiling point and melting point, we expect vapor pressure to decrease. If you increase the vapor pressure, we expect the melting and boiling point to go down, to decrease. Le nto ndifuna siyipicturishe. Ubuyaqaphela apha into esiyijongayo kakhulu yi-vapor. I-vapor is just evaporation. So yi-gas leyo sithetha ngayo. So i-substances zakho, they change from solid to liquid, then from liquid to vapor. So many of these organic compounds apha sifumanisa uba kulula ezinye uba zi-evaporize, ezinye zidinga i-energy. So then don't ndifuna sizijonga ezo. So it does affect as physical properties kwi-organic compound. Zindoni? Zinto esizibiza nge-intermolecular forces. These affect i-physical properties. Then as intermolecular forces zifumaneka phi? I-organic compound mos, we know indlela ezifomisheke ngayo. Kukho i-HC molecule, kubekho i-carbonyl molecule. Siyazazi masezi, si-ester, ketones, aldehyde. Sibe no-OH molecules, where sithetha ngantoni ke-alcohol and acid. Zezi zinto ezi. So apha kwi-HC molecule, we'll speak about its chain length and molecular mass. So kwenzeka ntoni xa ngaba i-chain length ye-alkanes okanye any of those compounds increase? I-mass yazo iya-increase kaloku. And siyazi uba apha kwi-HC molecules kukho apha i-London forces. Zii-London forces ezi zilapha. Then ezilapha ibe zi-dipole, dipole. Before so nazo eziphaya. Then apha kwi-esters, zi-esters ezi, the ketones. Then ezi ibe zi-hydrogen bond. Zii-moles zii-intermolecular forces ezifumaneka pha. Xa ezi intermolecular forces ziba ne-strength ezi-strong, that need more energy. I-energy yethu ihamba ne-heat. I-heat yakho involve melting and boiling point. That is temperature, which is heat. Masithetha ngaloo. So apha, if the increase chain length, kwenzeka ntoni? Le case yenzeka mostly kwi-alkanes, not disulfide. Yenzeka mostly kwi-alkanes. Xa ngaba u-increase mass yantoni? I-chain length ne-mass ye-compound. So apha, if si-increase chain length, kuza kwenzeka ntoni apha? Apha sizoba high strength of what? Of intermolecular forces, London forces. Then strength isenyuka, we will need high energy, which is melting point and boiling point. VP wako apa is very low. So that is what is happening here. So if we increase our chain length, intermolecular forces between those compounds, increase intermolecular forces up, so need more energy to break those forces. Then see a melting point and boiling point. Then the melting point is easy enough for a compound to evaporate. So note those things. So this is upper, we carbonyl, which is this one. Upper, London forces and the dipole. Three forces up is. So the dipole forces are stronger than London forces. So if upper on a carbonyl group with chain length, that affects its strength intermolecular forces. So if that strength is affected, surely we will need high melting and boiling point. Also vapor pressure will be very low. So after the effect, your functional group and structural formula here. Otherwise, if forces as corner, siyazazi already hydrogen bond, dipole, and London forces. So you must be able to place those forces kwindawo ezibhilanga kuyo. Then ujonge chain length yakho uba yenzani, also the mass uba kwenzeka ntoni xa i-mass ye-molecule i-increase. So that is what is happening. Also, OH bond. This one is the strongest of them all. Strong hydrogen bond, AC. So that means here, for us to break existing bonds as per, we need high energy. We need high energy, you see, to break as our forces corner apart, which is the intermolecular forces up. So now that we see thing of which I know about already, so by now I believe you can see that melting point and boiling point increases, vapor pressure going down. You already know that. But let's look at the graph now on how do these things are presented graphically. How do we present these things in the graph? Since presented is in the graphene. Let's draw on the part. So the format of graphically, ungayinikwa lento apha, unikwe temperature yakho, unikwe vapor pressure yakho pha. So apha vapor pressure 80 m no. Vapor pressure alkanes will be very short. Vapor pressure a carbonyl. Let's say it's not in Japan. So we know the atmospheric pressure kulapho vapor pressure ilingana the atmospheric pressure, and with vapor pressure kulapho sirisha khona melting point. Kulapho reach khona melting point. So when you look at these points, the point in point A, let's say graph A lo, graph B, graph C, and graph D. Somehow graph A takes shorter time, low temperature. Let's say 20 degrees, 30, 40, and 50. So graph A, uthatha only 20 degrees ukuze abe vapor, evaporize. Graph 30, uthatha 30 degrees. Then graph D, graph C, uthatha 40. Graph D, uthatha 50. So this is what is happening here. So singathi apha ezi ne-energy needs is, of which energy needs is intoni? The alcohol, the acid I mean, then OH law, which is alcohol law, then is the carbonyl, then OH law. So I believe now you understand this thing. Yes, let's move on. At the end of this case, so that the questions as long as I'm more now let's come to this part. These types of reactions as Dinga is. What about the reactor? As molecules. As react as molecules, funeka siyifumane reaction yethu uba injani kwenzekani. This you must memorize this. This is the simplest way yokufumana the types of reactions ezenzekayo xa ngaba organic compound. First ke sawuqala kwi-alkane. Zonke reactions eziphumayo kwi-alkane, sine-alkane apha, sine-alcohol, sine-haloalkane, sine-haloalkane, sine-alkane. So apha xa uphuma le isiza apha, sithi apha si-edisha phaya i-hydrogen. So from alkane to alkane, we add hydrogen. We call this hydrogenation. Then we use apha indol i-catalyst MPT. So make sure you memorize this. It will make your work easy. Open the questions back. Quick exam. From alkane to haloalkane, this is halogenation. So here we add X2. We know must use X for halogens. So this is halogenation. And then from this one to this one, see add and on up HX, which is halogenation. So the halogenation, there is no water here. No water. Okay. From alkane to alcohols, we add what? We add water. So this is hydration. And alpha, we use a catalyst, a sulfuric acid. I believe you see this diagram. Now this is just addition reactions zonke as alkene. Now note this. When we move now from haloalkanes to alkene, we need here, this is reaction condition. There's no name for this one. This is elimination reaction. We eliminate HX pa. Simkhupha ngaphandle. La HX besimfakile, siyamkhupha pa. Xa simkhupha la HX, i-condition yalapha ithi we need heat. Nantoni? Let's strong base here. We need heat and strong base. That is the mover from alkane to alkenes. We take out now that HX. Also here, we take out le water besifakile saformisha alcohol. Masifaka le water sisebenza now apha sulfuric acid concentrated plus heat. That is, we move now from alcohol to alkenes. These two reactions, the elimination reactions. So please make sure you memorize this thing and understand these conditions. So make sure you understand everything as in So dehydrohalogenation. So this is the reaction, dehydrohalogenation. We take out now halogenation. And dehydration, we take out now water. So when we say D, we take out something, ethyl to Londo, which is in this case alkane. So now let's look at this reaction now. What happened when we move from haloalkanes to alcohol? First of all, how do we form the haloalkanes? The haloalkane, they form the substitution reaction. Because the other OHX must add our HX, which is halogen. We add our X2 under the sunlight. Now, the catalyst the reaction ends under sunlight. So that is how we form the haloalkane. So talking about Ujapaya, la chlorine or any halogen atom to alkane. Ufumana don up. Ufumana bala X or one, also substitute hydrogen pa ashapu mela HR. The hydrogen asuka utibana nenye lesbini group 7 element. Then the formation doni the haloalkane. So now that is how it's formed. You will never see equation where you find out that you move from haloalkane to alkenes. There is no such reaction. So haloalkanes are formed, but as we elevate to alkane, we don't have such reactions. You can check maybe in your textbook and tell me. So now, how do we move now from haloalkanes, from alcohol to haloalkanes? When you look here, we've got OH here. This OH is alcohol, losing up the alcohol. Then masses of OH to form haloalkane. Because galogopaya is not reaction. Let's say the reaction is nile. These are hydrogens mostly. So paya is substitute. Is of one and the ban as haloalkane. Is of one as 7 is NaOH. You see. Sorry. Is of one as 7 is a paya OH PX. Plus HX, yes, HX, because it may not be bromine. So man about also the up lo X because negative ion and also negative. So the cipher is zombie label up, label pa. So fumane apa a molecule yako engban elotho. But now with X and basic hydrogen so is. That's why we call this haloalkane. So man abusuka from alcohol to haloalkane u etishabani alcohol. So apa ulo edisha OHX. So edisha HX pa alcohol ya. Then this HX afika substitute la OH ibuye lendo ibe paya. But now what if now ubuya what if ubuya from haloalkanes now to alkenes? So in this case, surely ubuze susepaya la H la X funeka edishe paya ibase yakho which is NaOH icondition yakho le with moderate heat. So make sure over his reaction you have to understand fully. These are your marks. You see. So from alcohol you add HX, you form haloalkane. Then from haloalkane you add this then this OH will go there. Yes. So guys, I believe nizibonile into besizenza pha, which means that diagram besinayo, we understand it perfect. Now what I will do, I'm going to do alcohols now. First, primary, secondary, and tertiary. What you must know is, in alcohols, une carbon bonded to OH. The carbon is ngayo. Then the carbon is bonded to OH. For example, this one, we've got OH here. This OH is bonded to one carbon atom. So this is how we name alcohol Z. So this is primary alcohol. This primary alcohol is very strong. It's very strong. So it's the strongest with alcohol Z. You see? So upper we just look at number of carbon as bonded to OH, to carbon carries OH. So on number 2, you've got same carbon, but with carbons as bonded to OH. Number the hydrogen is easy, but you've got OH part. So mawujonga apha, this carbon atom is bonded to 2 carbon atoms. So if it be 1 carbon, means by primary. Now the carbon it carries OH, it bonded with carbon atom as in B. So this is secondary alcohol. You see? And the secondary alcohol is weak than that one. Then in tertiary alcohol, this carbon, actually OH, is bonded to 3 carbon atoms. So let's look at this one. So the carbon E1, it carries OH, it bonded with carbon atom as that. So this make it tertiary what? Alcohol. So this is tertiary alcohol. Elena is highly reactive. Is highly reactive than a primary and secondary. So injalo i-alcohol zakho sizo ezi. So uma ngabunikwa any compound, especially alkanes, wanokufaka pha alcohol bakho, you have to calculate uba yeyiphi alcohol endiyinikwayo pha. Is it primary? Is it secondary? Is it tertiary? Then those alcohol ke ngoku uzoziplace ngokubona uba le bonded to this one, zingaphi ezibonded i-carbon to that one. So now, grade 12, we are done with this part. Let's take questions now, you see, on these things that sense life. This is born. Yes. Yes, guys. Remember, says Chilo. Starting now, we are looking at the questions. Let's look at these questions. Take November 2017, final exam, paper 2, question 4. So the ones are only as questions, another diagram, so only as the questions that are apart. So make sure to diverse a question paper with video. When they show everything, then is disappear, then depend the questions game. So make sure you are going to born up. For example, we are given this table. How strong as a reactions, never bond according to alphabets. We are bombas ni going on pa. So land is similar exactly to a diagram is now pi body. For example, number 1, 4.1 is P a primary, secondary or tertiary alcohol. That is number 1. When you look at P, now go P wako. Lastly, who connected to OH, bonded to 2 carbon atoms. So that simply means the secondary alcohol layer 4.1 secondary. You don't waste time, you just write what you see. You don't think. Hii reason yako usi bonded to OH is also bonded to 2 C atoms. We all see number 1. Go to number 2, 4.2.1. Write down the type of a reaction. When you look at the type of elimination reaction represented by A wako. So we know elimination is when sisuka kwindoni haloalkane sisiya kwi-alkene okanye sisuka from alcohol to alkene. So masijonga pha point A wako yintoni pha? We move from alcohol to alkane. Yintoni igama lala reaction? Dehydration. Just write, sikhuphi water phaya. Dehydration. 4.2.1 4.2.2 the addition reaction represented by B. Upi wako, we move from alkene to alcohol. We know most. We add water pa. So this is hydration. That is the type of reaction esifumanayo kwindoni kwi-addition. Number 3, elimination reaction represented by number D. When you look at number D wako, we move from compound X esimfumana ngo-add hydrogen bromide kwi-alcohol. So masi add hydrogen bromide kwi-alcohol. Nansi kaloku sithe masi add phaya hydrogen bromide to alcohol. So we move from here to there to alcohol. Then the formation on haloalkane. So now utango elimination reaction yenzeka pha xa ngaba sikhupha now elimination reaction represented by D. Where is number D? We move from haloalkanes to alkene. So we move from this one to this one. So the means I'm doing dehydrohalogenation. Sithatha phaya bromine siyibeka ngaphandle. Let's go to number 3. 3.1. Sodium hydroxide is used as one of the reactants in reaction C. As in reaction C, we move from haloalkane back to alcohol. We know a reaction between haloalkane and alcohol. Now, massive question here too. What type of reaction take place here? Also from alcohol to haloalkane. That is what? That is substitution reaction. There is no name here. Substitution reaction. 4.3.2. State 2 reaction condition for this reaction. So now, if we form a substitution reaction, then what is formation on? It's formation alcohol. So we move from haloalkane to alcohol. So if we never pass benaban kasuka from haloalkane to alcohol. If we never spend a moderate heat. Let's moderate heat up and a diluted base. Diluted base, which is NaOH, sodium hydroxide. That is number 2. 4.3.3. Write down the IUPAC name of compound X. Because it's compound X with from alcohol to compound X. Si substitute ile maspa. So la bromine is ungena pa sibenaban sibe no 2 bromo what? I believe you see it. Bromobutane. That is 2 bromobutane. Yes, 4.4. Write down the formula of an inorganic reactant needed for compound D. So for compound D, we need inorganic or NaOH or potassium hydroxide. Those are inorganic reactants. So from X to Y, we need pair. So let's move from haloalkane to alkenes. From haloalkanes to alkenes. So seneda banba. Seneda okay. From haloalkanes to alkanes. So seneda pair NaOH or OH. Now the inorganic reactant say to pa as dingagai. 4.5 using structural formula, write down a balanced equation for compound E. When you look at compound E, we move from alkenes now. We add hydrogen, which is hydrogenation. We form Z. We move from alkane to alkenes. We add H. So what is the structural formula? Very simple. So let me clean the pot. So here I'll have 4.5. So point Z. So I've got 4 carbon atoms. 4 carbon atoms. So this is it. That is, alkane is formed. Yes. So that is the structural formula of that product. 4.4. Now 4.6. 4.6, write down the IUPAC name of compound Z. Write down the IUPAC name. Using structural formula, write down a balanced equation for reaction E. Sorry, I swiped the answers here. The swiped answers. Okay. Let's start from 4.5. Then we move on. So in 4.5, using structural formula, write down a balanced equation for reaction E. So reaction E is that alkane, which is butane plus hydrogen. Then the product here will be that butane. So we are adding this hydrogen up. Sefumane the product here to pa. Ile. So now they are not balance equation yako pa. So addition hydrogen gas to bani to butane. Then safumana don safumana la product a alkane. So guys, I believe that's it for today. Yes.